Good morning all. In the previous two videos, we have seen about chemical bonding, the concepts of chemical bonding and an introduction to ionic bonding, Born-Haber cycle, etc. In the current video, we are going to discuss about covalent bonding. So first of all, let's see the definition of a covalent bond. We have already seen in the previous video that ionic bonds are formed by the transfer of electrons between the combining atoms, whereas a covalent bond is formed by the mutual sharing of electrons between the combining atoms. So here it is the sharing, no transfer of electrons. That means two atoms share their electron density between each other and thereby attain stability or octet configuration. And also the word mutual sharing is important because in this case, both the atoms should equally contribute towards bonding. Both the atoms should contribute at least one electron for a covalent bond formation. Because there is another type of covalent bond which is called coordinate covalent bond where there is sharing but it is not mutual. Both the electrons of the bond pair are donated or contributed from one of the atom. Anyway, that we will discuss later. So here, a covalent bond is formed by the mutual sharing of electrons between the combining atoms, and the theory proposed, the most important theory proposed initially to explain the covalent bond formation is valence bond theory. According to valence bond theory, a covalent bond is formed by the overlapping of half-filled atomic orbitals of the combining atoms. Half-filled atomic orbitals in the sense we know. Let's take the example of hydrogen atom. Two hydrogen atoms combine to give a hydrogen molecule, and each hydrogen atom is having a configuration of 1s1. That means each has one half-filled atomic orbitals. And these half-filled atomic orbitals overlap each other, or we can say the two s orbitals, each with one electrons, overlap each other so that both the electrons are now equally shared by both the hydrogen atoms and their valence shell will be complete. So this is how the covalent bond is formed, by the orbital overlapping or overlapping of half-filled atomic orbitals of the combining atoms as per valence bond theory. Now let's see the orientation of different atomic orbitals. As we know, an s orbital is spherically symmetrical. P orbitals are having dumbbell shape. The px orbital is oriented along the x-axis. The dumbbells of the py oriented along the y-axis, and pz orbitals are oriented along the z-axis. And also, the z-axis is assumed to be the internuclear axis. Similarly, two px orbitals or two py orbitals can combine only sidewise. Only sidewise interaction is possible for two px or two py orbitals. And this type of interaction results in a pi bond. So let's see in detail about sigma and pi bond. Depending on the extent of overlapping between the atomic orbitals, there are two types of bonds. They are sigma bonds and pi bonds. The sigma bond is formed by the head-to-head overlap or axial overlap between the combining atoms. So here we can see from the figure that two pz atomic orbitals overlap in a head-to-head fashion to form a sigma bond. The covalent bond is sigma. And also one pz orbital overlap with an s orbital in a head-on manner to form a sigma bond. Example for pz interaction is F2, fluorine molecule. We know the two pz atomic orbital of one fluorine atom overlap in a head-to-head manner with two pz orbital of another fluorine atom. Similarly, example for sp overlapping is HF molecule, hydrogen fluoride, where 1s orbital of one hydrogen atom, half-filled 1s orbital of hydrogen atom overlap in a head-to-head manner with the half-filled 2p-Z orbital of the fluorine atom to give a sigma bond. Since the overlapping is head-to-head, the sigma bonds are stronger bonds. And in the case of pi bond, we know the py and px atomic orbitals, they are not lying along the internuclear axis, and hence their orientation does not permit any sort of head-to-head overlapping. So here only possibility is interaction sidewise. They will interact laterally, or they will overlap laterally to form pi bonds. And these pi bonds are always weaker than sigma bonds. So a pi bond can be formed either between two px atomic orbitals or between two py atomic orbitals. Now, there is another classification of overlapping based on the signs of the lobes which are overlapping. So we can have a positive overlap, negative overlap, and also zero overlap. That means if the combining atomic orbitals, if the overlapping atomic orbitals are of same lobe, like the same sign, then it results in a positive overlapping. And if the lobes are opposite, if the combining lobes are of opposite sign, it results in negative overlapping. So positive overlapping is in phase and it is stabilizing and it results in bond formation. But negative overlapping is out of phase and it is destabilizing. And one more type of overlapping is there, that is called zero overlapping. That means no overlap is possible between certain atomic orbitals. That means between a px and an s orbital or a py and an s orbital, no orbital overlapping is possible because px and py, they are not along the internuclear axis. Similarly, between two px and py, no overlap is possible. Their orientation does not allow any sort of overlapping. So there is a zero overlap between an s orbital with a px or a py, or between two px and py. And positive overlap means we have the combining lobes are of same sign, and negative overlap means combining lobes, the orbital overlapping lobes are of different sign. So only positive overlapping results in a stable bond formation. Next is the classification based on the number of bonds between the combining atoms, number of covalent bonds. We can have a single covalent bond, double covalent bond, or a triple covalent bond. For example, in the case of hydrogen molecule, there is a single covalent bond between the two hydrogen atoms. There is only one sigma bond formed by the head-to-head overlap between one s atomic orbital, and that is called a single covalent bond. And in the case of oxygen molecule, we have a sigma bond as well as a pi bond. So that is called a double covalent bond. A double covalent bond is a bond in which two atoms share two pairs of electrons. And there is a triple covalent bond in which two atoms share three pairs of electrons, as in the case of nitrogen molecule. In nitrogen molecule, there is one sigma bond formed by the overlapping of two 2p-Z atomic orbitals from each nitrogen atom, and two pi bonds are also there. One pi bond formed by the sidewise overlap between two px atomic orbital, and the other pi bond formed by the sidewise overlap between two py atomic orbitals. So these are the three types of covalent bonds: single covalent bond, double covalent bond, and triple covalent bond. The formation of a single covalent bond we have already seen in the case of hydrogen molecule, where two 1s atomic orbitals overlap to form a sigma bond. Now, in order to explain a double covalent bond formation, let's take the example of oxygen molecule. We know the atomic configuration of oxygen atom is 1s2, 2s2, 2p4. So, valence shell contains 6 electrons and two of the valence orbitals are half filled. So these two orbitals should be fully filled in order to attain stability or octet configuration. So for that, what happens is two such oxygen atoms overlap each other, or the two half-filled atomic orbitals of each oxygen atom overlap. And we have already seen that only the 2p-Z atomic orbital can overlap in a head-to-head manner. So the 2p-Z, as shown in the figure, the 2p-Z atomic orbitals of the two oxygen atom combine head-to-head or axial manner to form a sigma bond, while the half-filled 2p-y atomic orbitals. The two half-filled atomic orbitals, the 2p-y atomic orbitals interact sidewise or lateral interaction results in a pi bonding. So this is how a double covalent bond is formed between two oxygen atoms. One is by the head-on overlap between the two 2p-z atomic orbital, and the other is by the lateral overlap between two 2p-y atomic orbitals, and thus a double bond is formed. In the same way, we can explain the formation of a nitrogen molecule. As per the atomic configuration of nitrogen, the valence shell of nitrogen contains 5 electrons, 2s2, 2p3. The 3p electrons are half filled, that is 2px electron, 2py and 2pz electrons. So these three orbitals require one more electrons to complete their octet. So two such nitrogen atoms with three half-filled orbitals undergo overlapping to form three covalent bonds between them. And among the three p orbitals, as we know, the pz alone can combine head-on-head manner to form a sigma bond. The px orbital and py orbital combine laterally. They undergo sidewise overlapping to give two pi bonds. So in the nitrogen molecule, there will be one sigma bond formed by the head-to-head overlap between two 2pz atomic orbital, and one pi bond is formed by the overlap between two 2py atomic orbitals, and the second pi bond is formed by the overlap of two half-filled 2px atomic orbitals. Thus, a triple bond is formed between the two nitrogen atoms, one sigma bond and two pi bonds. So, this is the formation of nitrogen molecule as per valence bond theory. In the same way, we can apply this orbital overlapping concept to explain the bonding in ammonia and water. In the case of ammonia, the nitrogen atom, the central nitrogen atom is having three half-filled p orbitals which will overlap with three 1s orbitals of hydrogen atom to form the ammonia molecule. And also in the case of water molecule, the oxygen atom which require two more electrons. Two of the oxygen p orbitals are half-filled and they require two more electrons to complete its octet. So these two orbitals will undergo overlapping with two hydrogen atoms to form water molecule. In this case, there is a difference that here, in each case, there is one central atom with other three atoms attached. So in such a case, the central atom before bonding or before overlapping, the central atom undergoes a process called hybridization, and the hybridized orbitals are combining with the 1s atomic orbital. So the details about hybridization and the different hybrid orbitals we can discuss in the coming videos. In these videos, we have discussed about the covalent bond formation and valence bond theory for explaining how a covalent bond is formed, that is by orbital overlapping approach. And we have also seen how sigma and pi bonds are forming. So in the coming videos, we can study in detail about molecular orbital theory, hybridization, etc. Thank you all.